1.7 linear inequalities. Okay, first we have to be able to know how to represent inequalities if we're giving them to you in this form, which is called interval notation. So a lot of times whenever you look at this, this is kind of symbolizing when you think of one dimensional that you've done with an open circle or closed circle. So because it's in between these two numbers, that means x will be in between them. Sorry about my chair if you can hear it. Now, when you're writing this with a -3 here and the 5 over here, when this is a parenthesis, that means it would be like an open circle. There's no line included. If this is a bracket, that means it would be like a closed circle. But we are not going to be using open circles and closed circles. We are just going to be using brackets and parentheses in interval notation. For this one, this is unbounded. If it's unbounded, you're going to just be looking at just the -3. This is where you have to use your brain. It says that the value for x is between a -3 and infinity. So if it's between -3 and infinity, that means x can be anything above -3. So that means x is greater than. And now you look at this -3. Does it include the -3? Nope, it does not. So that's the way it looks. I want you to pause the video and try to do C by yourself. So it should be in between 0 and 2, and they should both be or equal to. Now this last one is kind of tricky. If you're actually going to write out the interval, it would look like this, even though that's my or equal to x. However, at the same time, when we write this is the same thing as saying all real numbers. I would accept that. I would also accept this. I typically write this because I do. So when we're talking about number lines, how do we know? Because we've done inequalities on a number line and in a XY format. Well, it depends on how many variables we have. We only have one variable for all these problems, so it's going to be on a number line. So we're going to solve for x. I want you to pause the video and solve for x right now. When we get x is greater than 7. So when I make this on the number line, I don't need to have a lot of tick marks. You can. Some people love to have tick marks. I like to have one tick mark like this, and then the 7. That's my point. So now I'm looking, does that include that? No, we do not do open and closed circles. We do parentheses. Where is it going to point? It's saying x is greater than 7. Well, when I look at this number line, where is x larger than 7? It would be on this side. So when I'm drawing this on the number line, I would have a parenthesis and then a line going this way. That would be the graph. Now, sometimes you have it right on top of it, but then sometimes you can't see. So I'm not going to be too picky. I'll be equally picky as I can. I want you to try to do B, C, and D by yourself. Did you see my mistake in the first problem? That should be 8 because that should have been 16. So that should have been 8. For the second one, I personally like to make sure that my number is positive. Now, if you didn't get this exact answer, it would have been maybe confused with your negative. I added a 3/2. That's where this 5/2 came from. And then I added the 4. Multiply by 2, divide by 5. I typically visually in my brain, I don't like to see it like this, so I just flip-flopped it. Notice how this is pointing to the x. I made sure that when I flip-flopped it, it's still pointing to the x. So x is less than 2, it's brackets because it includes, and then it's less than, so it's pointing to the light. X is less than 2 again for this one. X is less than 3. This one is parenthesis because it's not including. So what if I have a double wobble? Well, some people solve these a little bit differently, but one thing you know for sure is that it's going to be bounded. What I personally do when I solve these, I solve 2 equations at the same time. So if I add one here, and I add one here, and I add one here. So now this will become a -2 less than or equal to 6x less than or equal to 4. If I divide 6 here, divide 6 here, divide 6 here, now what I have is -1/3. My x is in the middle, and then my 2/3 here. Now if I'm going to graph this, again, my point of interest is going to be at -1/3 and 2/3. And when I look at this, they're both brackets. Oops, sorry. No, this one's not because I miswrote that. So this one would be a bracket because it's including -3, and this one is a parentheses because it's not including the 2/3. Pause the video and try to do B by yourself. Both of them should have been parentheses in between -3 and 2. Our last example, because I did not put this on the next page, sorry about that, is absolute value. This is where you have to remember absolute value right here actually have two answers. So what we have to do, these are all kind of easily written for you because the absolute value is all by itself already. So I made your life easier to begin with. Because the first thing is always to try to get the absolute value by itself. Now to take away the absolute value, you have to write a second equation. Because we will have the equation x minus 5 is less than 2. Then we also have to write the equation x minus 5, since this always makes it positive, could also be negative 2. When we write that negative 2 though, remember with inequalities, if you multiply or divide by a negative, so this is kind of like me multiplying by a negative here, this sign flips. Now I solve both of them. I have x, I add the 5 is less than 7. Here I have x, I add the 5 is greater than 3. Now when you do this, either it's going to be bounded or else it's going to be pointing out. But our 2 points, this one's a lot smaller, so the 3 should go on the left-hand side. The 7 goes over here. I had to decide, am I shading in between or am I shading out? Now, this kind of is a hint, a short way or a gimmick way, I guess you could think, but less than, when I start with a less than, this is an and symbol. If it's an and symbol, that means it's in between. So at 3, it is a parenthesis. At 7, it's a parenthesis, and it's in between. Now I can always check that work. So in between these numbers is 5. Is 5 less than 7? Sure is. Is 5 greater than 3? Sure is. I want you to try to do B and C by yourself. The first one you should get 4 and negative 11. Second one, 24 and 16. This, I started with a great or. Or statement looks like this. So at 4 and 11, or statement means it's shooting out. That means it's going to include it. So it's a bracket at both. Bracket, bracket. And it's going to be shooting out from the brackets. Again, I would check it. Now you could either check a spot on either side, or I'm going to check 0. 0 should not be a true statement. So is 0 greater than 4? No, that's good. Is 0 less than negative 11? No, and it shouldn't be because I checked a spot in the middle. Same thing when I'm looking here. Less than, so this is an and statement. So and statement, since it's including them, should be both bracket and it should be shooting in the middle. So shaded in between. So again, I'm going to check number in between this. So I'm going to check 20. Is 20 less than 24? Sure is. Is 20 greater than 16? Oh, that it is. And that's all we have here. Have a wonderful day.